All right, we have a lesson today where we're going to look at the trig values in the four quadrants. Now, we in our last lesson we took a look at reference angles, and now we're going to extend that to reference triangles. We kind of went quickly through the reference angles. I don't know if you have a really good understanding of why we did it, and I think you know how to find a reference angle by now, or I hope you know how to find a reference angle by now. But in case you don't, we're gonna review that. Like for example, here, the reference angle is 35 because we have a 145 degree angle. So if you draw the 145 degree angle, it would stop right about there. Okay, and then you would want to figure out how far more you'd have to go to get to the x-axis or to get to 180. So you just take away 180 minus 145 and you get 35. So that's why 35 is the reference angle. Now, a reference triangle is going to be basically just taking from that terminal side that we already know how to draw and just going straight down from a given point on that line. You'll be given a point, and then you just draw straight down to the x-axis and then back to the origin, and that creates a right triangle. And that's kind of how we're going to be studying our trig the rest of the way. Okay? So this is a reference triangle here, a reference triangle with a reference angle of 35 degrees. And that would help us. A reference angle of 35 in quadrant 2 is going to give us any information we need about a 145 degree angle as far as sine, cosine, and tangent. Now, in Algebra 1, and not only Algebra 1, but in geometry, you studied sine, cosine, and tangent, and now we're going to go a little, continue on from there, what you learned, and extend what you learned about sine, cosine, and tangent. So we're going to review what sine, cosine, and tangent functions are. The sine function is a ratio of the side opposite an angle to the hypotenuse. So it's opposite over hypotenuse, O over H. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. That's for right triangles. So you may have learned, or you may have learned it this way: so ka toa, so ka toa. To remember what they are, sine is opposite over hypotenuse, OH. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So ka toa. Adjacent hypotenuse, opposite adjacent. Okay? And that's one way to remember it. When I was younger, we learned it. Some old horse caught another horse taking oats away. All right, there's lots of ways to remember these. But bottom line is you need to know this. These are the definitions of sine, tangent, and cosine. So how do I get a reference triangle from a point? So say I have the point 3, 4. Well, first of all, you got to know what quadrant you're in. The point 3, 4, you just plot it, right? 1, 2, 3, 1, 2, 3, 4. So it's going to be somewhere here. Just estimating, right? So let's say it's right there. All you do is draw from the origin to that point and then straight down perpendicular to the x-axis. And that's your reference triangle right there. Okay? So if this is the point 3, 4, that to get the 3, it's 3 to the right. To get the 4, it's 4 up, right? You go left and right, then you go up and down. The x goes left and right, the y goes up and down. So the length of this side of the reference triangle is 3. How do I know that? Well, I went from 0 to 3. 0 to 3 is 3, right? To go from up, the length of this side of the reference triangle would be 4 because it's 0 to 4. All right, that's a length of 4. So we basically have a triangle that's a 3 and a 4, a right triangle that's a 3 and a 4. And how do we find the last side of a right triangle? If you know two sides of a right triangle, you could find the third side from the Pythagorean theorem. We all love the Pythagorean theorem, right? Super easy. 3 squared plus 4 squared equals c squared. Remember, a squared plus b squared equals c squared, Pythagorean theorem. So this is 9 plus 16 equals c squared. 25 equals c squared. And then we take the square root, and c is 5. So we know that the hypotenuse of our reference right triangle is 5. So essentially, I'm just going to blow this up a little bit. Essentially, our reference triangle is a 3, 4, 5 right triangle. Does everyone see that? All right. Now, our reference angle is always at the origin. So I'm going to try and mark that here the best I can in red. The angle at the origin, right there, the red angle there, that is the angle that we use for reference. So when they're asking for the sine of theta, that's theta right there. That's theta, angle theta. So based on theta, sine is opposite over hypotenuse. We've got to use the definition. Opposite is 4 over the hypotenuse, which is 5. 4 over 5. The cosine is the adjacent over the hypotenuse. The adjacent is 3, and the hypotenuse is 5. So 3 over 5. The tangent is opposite over adjacent. Opposite is 4, adjacent is 3, 4 over 3. Now, if I went too fast and you didn't really understand that, I'm going to have to maybe explain it a little better in class, because I'm assuming you know the basics of trig coming in. If you're like totally mind blown, like I've never seen sine, cosine, tangent before, you're probably having trouble with this, and I'm going to have to explain it to you a little bit better in class. So just kind of roll with it for now using the definitions, and I think maybe you'll pick it up as we move along here. Pythagorean triples, 3, 4, 5, 5, 12, 13, 8, 15, 17. Those you might want to memorize. Why do they work? 3 squared plus 4 squared equals 5 squared. We already showed why. Another one is 5 squared plus 12 squared equals 13 squared. These are whole number Pythagorean triples, where you could have, if you had this one here, I'll draw it on the side. If you had a right triangle, that doesn't look like a right triangle, and you had a 5 and a 12, you would know that the hypotenuse is a 13. If you knew a 5 and a 13, you would know this is 12. If you knew 12 and 13, you would know this is 5. You could just memorize 5, 12, 13. Because it fits into the Pythagorean theorem. 25 plus 144 equals 169. 25 plus 144 equals 169 if you actually multiply that out, or square these out and then add them. This is another one. 8 squared plus 15 squared equals 17 squared. You don't have to memorize these. They're just shortcuts. You can always just do the Pythagorean theorem. So if you're like, what the heck's he talking about? Don't worry about it until you get better at it. Then you might memorize it. All right, so another one here. So now they're giving us a point. Just going to erase this because it's in the way. They're giving us a point, -5, -12. And we're going to put that on. We're going to make a reference triangle here. So -5, -12. You got to know what quadrant you're in. Negative, negative, left down is going to be quadrant 3. It's going to be down here. So left and down. I don't know where -5, 12 is. I'm just going to mark it right there. Let's say that's -5, 12. So again, you go from the origin to that point, and then you go straight up to the x-axis. And there's your reference triangle. So we're going to go -5, -5, and -12. This one's -5, and this is -12. How did I know that? XY. It's XY. First one is going to go to the left and right, and then the second number is going to be the up and down. So it went left 5 and down 12. So I need my hypotenuse length. 5 squared plus 12 squared equals c squared. We already know it's 5, 12, 13. So I already know this is going to come out to be 169 equals c squared. Then I take the square root, and I get I get 13. So c is 13, and that's going to be our hypotenuse. Our hypotenuse is always positive. It's always positive. All right, so now we can do our sine. Our sine is going to be opposite over hypotenuse. So again, here's my theta right there. This is my reference angle, always the angle at the origin. From that angle, from this angle, the opposite side is -12. So it's opposite over hypotenuse, which is 13. That's all we want to do. The cosine, adjacent, -5 over hypotenuse, 13. And then tangent, opposite, -12 over adjacent, -5. Opposite over adjacent. And then negative over negative is positive, so this just comes out to be 12 over 5. So my tangent is 12, the ratio 12 over 5. All right, moving on. We'll fly through this page pretty quickly. So quadrant 1. We want to consider an angle of rotation for each quadrant, because we may have a quadrant 1 angle, a quadrant 2, quadrant 3, quadrant 4. We talked about different quadrant angles in our last lesson. So if you're in quadrant 1, what's nice about quadrant 1 is everything's positive. Because say you have theta right here. Well, opposite is positive and the hypotenuse is positive. So it's positive over positive, which is positive. If you're looking at the cosine, it's adjacent over hypotenuse. Positive, positive. Positive divided by a positive is a positive. All right? If you're looking at the tangent, same thing. Opposite over adjacent, positive, positive is positive. So all three trig values are positive in quadrant 1. Everything's positive. You're going to the right and up. Everything's positive. Quadrant 2, a little bit different. You go over to quadrant 2, your x is negative. All the x values are negative. So our adjacents, all our adjacents are negative, and our opposites are positive. So sine is still positive. Opposite over hypotenuse. Cosine, adjacent over hypotenuse. Adjacent is negative. Hypotenuse is always positive. A negative divided by a positive is a negative. And then the tangent is opposite over adjacent. A positive divided by a negative. Positive divided by a negative is a negative. So in the second quadrant, only sine is positive. Only sine is positive. In quadrant 3, we got to do it now. Here's our angle. Opposite is negative. Hypotenuse is positive. A negative divided by a positive is a negative. In quadrant 3, the cosine adjacent is negative divided by a positive, which is negative. The tangent of this angle, opposite over adjacent, look at these two. It's negative divided by a negative. A negative divided by a negative is a positive. So the only thing positive, only the tangent is positive in quadrant 3. And then you go to quadrant 4. We got to fill them all in. It's a positive x and it's a negative y. R is always positive. So opposite, here's our reference angle right here. There's our reference angle. Opposite is negative, hypotenuse is positive. Negative, positive gives you a negative. Cosine is positive, positive, which is positive. And then tangent is negative, positive. Negative, positive, which is negative. So only cosine, wow, COS, is positive in quadrant 4. So each function has its own quadrant where it's positive, the other functions are negative. Here's a summary of what we just did. In quadrant 1, everything's positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. In quadrant 4, only cosine is positive. Take the first letter of each one. All positive, only sine positive, only tangent positive, only cosine positive. All, sine, tangent, cosine. A, S, T, C. This is called an ASTC diagram. You'll hear me say, draw your ASTC diagram. Your ASTC diagram. Your ASTC diagram helps you determine whether the functions are positive or negative. All right? And a way to remember ASTC, you could say all students text constantly. All students text constantly. ASTC. That's a mnemonic device to help you. All students text constantly. Okay? ASTC. ASTC. And it goes quadrant 1, quadrant 2, quadrant 3, quadrant 4. In that order. 1, 2, 3, 4. ASTC. Got to remember that. Okay? So we're going to do our examples here. What we're going to do here is we're actually going to go through these in class because, especially example 2, well, we'll just do them all in class. But example 2, you really need your graphing calculator for it. So it's not going to. If I just do it for you, you're going to be like, "What the heck's he doing?" It's not going to make any sense for you. So long enough video. We got the background information we're going to need. We're going to do the examples 1, 2, and 3 in class tomorrow when I see you. So see you then.